So we learned U sub, and we also at the same time learned how to do some subtle substitutions. In other words, we're raising that difficulty level on those substitutions. All right, so let's practice that. Now the top one is one you probably have seen before. You rather obviously know that U is 3x plus 2, right? Because it's inside another function. No, not a hard problem. But then du would be 3dx. Well, I don't want the 3, but I do want the dx. So I want 1/3 du. But I have a problem. I have an x left over. So if I rewrite this right now, I know that I'd want a third. I'd want an integral sign. Leave yourself some space right there. And then you want the square root of u du. The problem is that you cannot put x there. You cannot have two variables with one integration symbol. That's no. Not allowed. So we need to find x. So we need to find a formula for x. Or not formula, but we need to find x in terms of u. Let me put it that way. Okay. Well, I know that u is 3x plus 2. So couldn't I solve that for x? U minus 2 would be 3x. So u minus 2 over 3 would be x. Or it would be 1/3 u minus 2/3 if you want to do it that way. Either way, I'm going to do this one right here. So I'm going to take this and say, hey, that is u minus 2 over 3. Right? There's my x. There's my square root of 3x plus 2. And then the 1/3 du gets me my dx. Right. Wonderful. So now let's do some work here. Now I'm going to take the 3 that was out here and the other 3, and together they make 1/9, right? Because they're multiplied. And then I'm going to have a u minus 2 times a u to the 1/2 power. So hopefully you can feel what's about to happen. I'm about to distribute, right, using one of those other techniques. So this is 1/9 integral of, okay, so this is u to the 1. U to the 1 times u to the 1/2 would be u to the 3/2. I'll just write it with blue. Minus, because of that minus right there. And then it would be 2u to the 1/2, right? So 2 times u to the 1/2 du. The du, of course, ends my integrand. So if the integral symbol begins it, then the du ends it. Okay, so then this is 1/9 out in front. And then you raise the power and multiply by the reciprocal of the power. So it's 2/5 u to the 5/2 minus, there's a 2 already there. And then I'd multiply it by 2/3 u to the 3/2 plus c. All right, now I'm going to do two things at once, actually. I'm going to put back in what u was, but I'm also going to distribute. So this is 2 over 45, and then u was 3x plus 2. So 3x plus 2 to the 5/2 minus, and that's a 4. 2 times 2 is 4, over 9 times 3 is 27. So 4 over 27, and then it would be 3x plus 2 again to the 3/2 plus c. So what makes it subtle is, I mean, if we think about the subtle piece, it's this piece right here, right? That right there is what makes it more difficult. The fact that you have to solve for x, because you're not allowed to mix and match variables. So sorry, I'm running at the end of my paper there. So I have to make a comment about that. All right, now usually you've seen this one that we just did in Calc 1, so that's not so bad. All right, now what about this one? Well, we're actually going to try a couple different things. Let's see here. If you think to yourself like, oh, okay, I could just use U sub right away, no problem, you're going to run into a little bit of difficulty. Because if you try to make U the denominator, the derivative of the denominator is not that numerator. Grr. So we're actually going to combine. We're going to do something else. So I'm going to combine techniques here. I'm going to rewrite it as e to the x over e to the x minus 2e to the negative x. And now I can multiply by whatever I want. So I'm going to multiply this by an e to the x over an e to the x. Why? Well, because I can. I can multiply by anything I want. I can multiply it by, I don't know, x to the 5th power if I so desired. It's just almost everything I would multiply by wouldn't do me any good. This particular one will do me some good. And the reason it's going to do me some good is actually right down here in the bottom term. But I'll show you in a second. So this is the integral of, okay, e to the x times e to the x is e to the 2x. Now remember, that division is a grouping symbol, right? So you're multiplying everything down there by e to the x. So it's e to the x times e to the x, which is another e to the 2x, minus, and then here's the real kicker, 2 e to the negative x times e to the x is e to the 0, right? E to the x, e to the negative x is e to the x minus x, which is e to the 0, which is 1. So actually, let me put it that way, it's that. Here, I'll make a little star. That's why that's happening. Nice, huh? You're thinking, well, that didn't make anything as easier. Oh, yes, it did. Because that denominator is your u. And that numerator is mostly your du. Du would be e to the 2x, because the derivative of e to the x is e to the x. But because there's a 2x, you'd multiply it by 2. And then minus the derivative of 2 is 0, so nothing. So I would want 1/2 du. There we go. So for dx and e to the 2x, those two are taken care of as long as I write the integral of 1 over u. And I write a du, but du is too large, so I have to put a half in front. Well, this is quite easy. This is a half natural log. Don't forget your absolute values, which is a half natural log absolute value of e to the 2x minus 2 plus c. Handy, huh? And I know what you're thinking. You're thinking, well, how would I ever know to do e to the x over the x? And the answer is you don't necessarily right off the bat. You play around. You try different things. So if I tried to factor this, it wasn't helpful. If I tried to cancel, it wasn't working out. You can't really cancel. You'd have to factor the denominator, and it just didn't get me anywhere. You play. You play until you find the right thing. That's how you find it. It's not a magic process. It's a hard work process. You work at it really hard, and eventually you'll get there. All right, we have time for one more technique. So we saw subtle substitution. Let's talk about splitting up fractions. In other words, decomposing fractions. And we're going to do a lot more on this, more difficult ones in section 8.5. Things are going to get so much fun in that section. So we'll see this later. But for right now, that all we're going to do is pretty basic one. Now remember, when you're splitting up a fraction, when you're decomposing a fraction, you can only split up the numerator. You can't split denominators. Denominators don't work like that. It's against all the rules, all the algebra rules to split up a denominator. Okay, so this sounds, what do you mean denominator? Watch. You take this integral. We actually kind of do this all the time without even really thinking about it. This is x squared over x plus 1 over x. Huh? So this is the integral of x. Technically, I could split them up entirely, but we don't always have to do separate integrals for each, but I will. It's no big deal. I've split up my fraction, right? That's the important part. So this part right here is a half x squared, and this part is the natural log of absolute value of a half, and you're done, right? You split up the numerator. You can only do it when there's addition or subtraction in that numerator.